Hey guys, it's Miss Briggs. This is homework help for this week's homework. So I decided to spice it up a little bit with some instrumental music in the background, courtesy of Happy Instrumental Piano. So let's get started. The first question that we're looking at is number 4, which says the table below lists the metals used to make a $1 US coin and the percent of each metal in the coin. Based on the information in the table, which statement correctly describes the coin? So, remember that we're going to be looking at a coin. We need to look at the table here, familiarize ourselves with it. Notice that the copper has the most here. And then just kind of make some other observations about the table as we dive into what's next. It is a compound because it's made up of different metals that have chemically bonded together. Well, I know that one could be true because when I have all these metals, they are now joined. They're not separate. So they're put together. They've chemically bonded. It is a pure substance because it is made up entirely of metal. Well, I know it's not a pure substance because it has 4 different types of metals in here. It is a mixture because it is made up of different metals that do not react to form new substances. Well, I know that one's not true because we have a new substance in that we have the coin, all 4 metals, put together into one. Jay says it is a magnet because it contains metals that attract iron. Just because it has iron in it, actually this one doesn't even have iron in it. Hang on. This is totally just a trick. Look at that, they almost got me. We know it's not a magnet because it doesn't have any magnetic properties. Just because it has the nickel, which I know is magnetic, doesn't make that a magnet. Ha, gotcha, take that. So, correct answer for this one is F. Number 7, a student stirs salt into a glass of water. After a few moments, the salt is no longer visible. Which statement is definitely true? The substances in the glass can be separated using a filter. False. I know that when I have a glass of water, with my little packet of salt that I've put in there, it has fully dissolved because the particles have spread evenly throughout the mixture, or throughout the liquid. And I wouldn't use a filter to separate it because all that's going to happen is the salt water is going to go straight through the filter. The substances in the glass cannot be separated using physical methods. Well, that's not true either because if I have my little Bunsen burner here and I heat it up, I can go ahead and start to separate it and I'll see my steam rising off. The glass contains a mixture of the same substances as before. Not exactly true. It does have the same substances of both salt and water, but the water has now changed, so it's not the same. The glass contains a new substance with a different chemical identity than before. That's true. Before, it only had the water in there, but now I have salt water, which is a different chemical compound and chemical identity. Number 12, students are investigating a mixture of oil and water. They notice when the mixture is stirred vigorously, it appears to mix evenly, but after letting the mixture rest, the oil floats on top of the water. The students are making, so we need to go through here and decide. I'm going to go ahead and start at J because I know they're not making a prediction. They're not guessing anything. They are noticing things that are happening. An observation? That one could be a very good answer because they are noticing, they're observing something that's happening. They haven't drawn a conclusion yet because they haven't decided exactly what that means. And an inference, no, they're not drawing it. They're not drawing an inference here, right here. They're really just noticing, which would go under making an observation. Next question, use the diagram below to answer and your knowledge of science to answer questions 13 and 14. So talking about simple mixtures, which has been a lot of fun this week. Which of the following belongs in rectangle A of the diagram? So I know that I'm looking for simple mixtures. I have fruit salad, soil, and something else. So I'm going to start checking through my answer choices. I know the word assorted means it's got a variety. So assorted nuts means there's more than one kind. They're all mixed together, but they're not bonded, so that one could be my answer choice. Strawberry gelatin, that's a fancy way to say Jell-O, and I know that Jell-O is not a mixture. Baked bread. Well, when I bake the bread, it actually has a new identity as a whole or a uniform compound, so it's no longer a mixture. shelled peanuts. That, my friends, is just a peanut that's out of the shell. That's only one thing, so it's not a mixture because it's just the one item. Best answer there is A. Next question, number 14. All of the following could complete rectangle A in the diagram except what? So remember that we had simple mixtures in our diagram. Boop. So trail mix is a mixture, it's in the name. A sandwich. That one I would classify as a mixture because I can easily separate the parts of the sandwich into their individual pieces. Currently, they're all compounded together, but I can separate those parts. Peas and carrots, I can easily separate. Lemonade, however, is a solution. A solution is different from a mixture because the particles that have been put into the solvent are spread evenly. Sorry about that. Are spread evenly, which is different from a mixture. A mixture, just like we saw in our video the other day, means that I won't always grab equal amounts. But with a solution, I know everything is spread out evenly. And we had one more question. Dear Miss Briggs, I actually have a question. So if you have, let's say, lemonade, if you add another liquid like Kool-Aid, will the physical properties change? Please answer before we start a whole new thing. Thanks. So yes, the properties are going to change because before you had a glass of lemonade, and then you have your glass of Kool-Aid. So you're changing the Kool-Aid and the lemonade because think about it. If you start combining those, now you have a lemony Kool-Aid. So it's changing both the chemical structure of it by no longer just being Kool-Aid and no longer just lemonade into a combination of both. So there is a change to the properties as asking the question. You can kind of think about it like if I had just water and then I add salt, it's a new component because I know that they are both soluble. The components that would go into lemonade, whether you use powder, use sugar and lemon juice, those are solutes, and so they're going to dissolve into the water. Same with our Kool-Aid mix and our powder that we would use. That is also soluble. And so since both are soluble, they're going to continue to dissolve together here to make a new compound. Thanks so much for watching. If you have any questions about these, please feel free to comment below. And please be sure you put questions in my mailbox for next week's homework. I'll try to have the videos up Thursday. And also just a little PSA, I'm working on grades tonight. Sorry for the delay. It's been really hectic the last few days with all this crazy weather, but yeah, so those are going to get updated really, really soon. I've been grading through, seeing some really good stuff. I really liked what I saw today that we were working on with how we're separating mixture. So let's keep it up, and don't forget, we have a test tomorrow. See you guys.